This lecture is about inferential statistics from a conceptual point of view. I want you to be really familiar with what I'm talking about when I say inferential statistics. Let's start with what inferential statistics really is. It's actually a set of procedures and models we use to make inferences for a population. In other words, we use analyses to find out something about a sample from a population, and then we infer conclusions about the entire population. This kind of shows the steps that we go through. We start with the population, we take a sample, we do an experiment on that sample, we analyze the data, and from that we can make inferences that lead us back to knowing something about the population. Why do we bother to sample? Well, there are three reasons. Instead of running analysis on the entire population, first of all, it's usually impossible to do that. For example, if I want to learn something about fourth graders, that is a huge population, even within one good-sized district. Now imagine that I want to learn something about all fourth graders in the US. Obviously, it's impossible to gather data from every fourth grader in the whole country. Second reason is cost. Even if a population is manageable, say all the homeowners in Clark County, the cost can be prohibitive. Cost includes your time, the funding for gathering the data, and the time, energy, and cost of actually doing the analysis. It's just not reasonable. And last of all, and this is really important, there is no need to run the analysis on an entire population. Statistically, we can use a sample and confidently make inferences about the population. So it makes no sense to gather data on the entire population. Sampling refers simply to identifying a small group of participants or subjects that will represent the population. Sampling is not confusing. What can be a little less clear, though, is what the population is, and the researcher in anything you read must define that population. If I make a sample of 300 third graders in a large urban school district, what population does that sample represent? I have to be really clear about that. Can I use the data to make inferences for third graders in large cities? How about third graders in the whole United States? Or can I only make inferences for students in that particular district? It's my responsibility as a researcher to spell out the population I'm studying and how that sample represents the population. Sampling follows well-established procedures and guidelines. There are well-documented boundaries for sample size. The researcher has to ensure that the sample size is large enough for the analyses that are going to be done. In addition to considering the size needed, a researcher must also determine the procedures for sampling so that it matches the research design that's going to be used in the experiment. So let's look at some sampling procedures. The gold standard for sampling is random selection. When I randomly select my sample, I consider all the possible participants, in other words, my whole population. Then I ensure that each member of that population has the same chance or probability of being selected for the sample. As your textbook points out, it's impossible to make the odds always exactly the same. If I have a population of 100 students, I randomly choose my first sample subject, and all of those students have a 1 in 100 chance of being that first subject. But once that subject is identified, I'm down to 99 students in my population. So when I'm selecting the next participant, each student has a 1 in 99 chance of being selected, and so on. But we honestly don't do it that way. If I need to randomly choose 21 students from a population of 100, I actually choose 21 simultaneously, so each of the 100 has the same chance of being selected. It'd be like reaching into a hat and pulling out 21 names all at once. This is actually really easy to do with the technology that we have. The next concept you need to understand is random assignment. This happens after the sample has been selected. So if I need 3 groups to compare, I would randomly assign my 21 students in the sample to 3 different groups. Be sure that you understand the difference between random selection, which is where you select a group out of the population, and random assignment, which is where you take that sample and then randomly assign people from that sample into different groups. You will find studies that did not have a randomly selected sample, but then the subjects were randomly assigned to groups. And this is really common in educational research. There are variations on sampling that are not necessarily random. First of all, systematic sampling. Systematic sampling means that you decide on an interval and you take that name on the list. This is pretty straightforward. So maybe I'm going to take every 10th name on the list or every 15th name, etc. Please do not consider this random. The classic caveat is always that lists, by the nature of being a list, are organized. They may be organized by a name, an age, an ethnic group, by the order somebody put the name on the list. Think of any way you could possibly sort a list, and any of those sorts remove the randomness. Stratified random sampling can be random, but it takes advantage of being able to sort a list. For example, say I'm doing research at a four-year college. I may want to ensure that freshmen, sophomores, juniors, and seniors are all equally represented in my sample. So I could sort the list of students by year, then randomly select a sample from the seniors, from the juniors, and so forth. Stratified random sampling could allow me to either pick equal numbers from each category or a proportion that represents that category. So if 17% of the students in my population are seniors, I may choose to, out of the senior group, I may choose to randomly select 17% of my participants. Keep in mind that simple random selection, if truly done mathematically, will ensure that all the groups are represented in the sample, usually in proportion to the size of the group. So if the size of the sample is appropriate for the population size, you really do not need stratified random sampling very often. But there may be some research questions that require it. Finally, there is cluster sampling. That means that I randomly select, this is random, a group, but it's the group that's the random part, and the whole group then participates. If you're part of that group, there's nothing random about you being chosen. You're chosen because you're part of that group. Often in educational research, we randomly select classrooms. It's darn hard to experiment with some children in a classroom and not with the others. It's much less disruptive to work with a whole classroom after all. Let me walk through the process with an example. Being able to read at grade level is incredibly important to an elementary student's predicted success in school. So interventions are often used for students who are not reading on grade level. Let's pretend we have a fairly new intervention that is used with third grade students who are not reading at grade level. We have 30,000 third graders in this fictitious state. So the researchers decide they need a sample of 400 third grade students. They use a computer program, to randomly select 400 of the state's third graders. Then they randomly assign 200 students to use the intervention and 200 students to not use the intervention for a control group. Note that the independent variable is the intervention, and it has two conditions: using it and not. It's rather obvious that this is going to be very, very difficult to have 200 students randomly chosen from across the state using the intervention and 200 who are not. So it would be more typical to randomly select 16 classrooms of 30 students in each classroom rather than selecting individual students. Then we could randomly assign 8 of the classrooms to the intervention, and the other 8 are our control group with no intervention. This is an example of cluster sampling. Perhaps, though, we want to ensure that every district in the state is represented in the samples. In that case, we would randomly select a number of students from each district. Then we would have to assign these students to a condition. This would be an example of stratified random sampling. Perhaps for some reason we want to use systematic sampling. I don't know why. I'm not a big fan of systematic sampling. We simply list all of the third graders and then select every 120th student in the entire list of all the third grade students in the state. We would then randomly assign them to two different groups. This would be an example then of systematic sampling. It should be obvious to you now that there are many, many, many ways you could combine random sampling with random assignment. Perhaps it's not going to be random selection, but you can randomly assign them to groups. There are a lot of different combinations. So we have a sample of these third graders through whichever method we decided to use. And that sample, those 400 kids, that we chose out of the 30,000, that's our sample, and they represent the population. If it's truly random, that sample has very close to the same characteristics as the population they represent. Next, I set up my experiment. I have two conditions of the IV, which is the intervention. I'm going to use reading scores from a test as the dependent variable. So I have my intervention group use the program while my control group does not, and then I give them both the test to get the scores on the dependent variable. After I give the students a test, I analyze the results for each group. Finally, I take those results. Let's say I find that the best thing since sliced bread led to a statistically significant greater gain than the control group had. I then infer that this finding can apply to all of the entire third grade population in that state. So that, in a nutshell, is what inferential statistics is all about. The rest of this course is going to focus on some very basic analyses we do in order to make those inferences about the population.